Do you know the way the elements are arranged in the periodic table? By their order of increase and decrease in atomic radius, ionization energy, electron affinity, and electronegativity? Let's talk about it now. Please subscribe to my YouTube channel. Like, comment, and also share. So at any time I post a new tutorial, YouTube will notify you. Everyone know what is this. Even if they don't know much about chemistry, it's a periodic table of elements, which first seems like a random arrangement of substances, which sounds foreign and strange. But the way the elements are arranged reveals more beautiful pattern that tells us how nature operates. In the 80s, a lot of chemists were trying to come up with a way to, to depict elements, to depict all elements in a table form. And many different formats were proposed. But it was the one by Dmitry Mendeleev because of how well it correlates data as well as its predicting powers. He arranged elements in a rows called periods and in a columns called groups. Elements that has the similar behavior were put in a group together, which helps to correlate existing data. And he also predicts existence of elements that has never been seen before with a gaps in a table. So there must be an element that goes in this plot, and he predicts some of their properties. And eventually, these elements were discovered with a property precisely as expected. Now we have all the metals, the metalloids, and the nometals nicely. Please subscribe to my YouTube channel. Like, comment, and also share. So at any time I post a new tutorial, YouTube will notify you. It wasn't known at first, but the reason elements in the same group behave similarly is because they have the same number of valence electrons. Look at group 1, for example. These elements all have one valence electron or one electron in their outermost shell. As you go down the group, the number of energy level, which is N, increases. You gain a shell each time, but whichever is the outermost shell, there is only one electron in it. Every element in group 2 has 2 electrons in its outermost shell. This simple fact determines many characteristics about each element in ways we will continue to see as we learn more about chemistry. There are some periodic trends that we can recognize when we look at the table. First, atomic radius, or the size of the atom. As we proceed downwards on the table, atomic size increases because we had shells. As we go to the right, atomic radius decreases because we are moving within the shell. and each element to the right has one more proton in the nucleus than the last. So there is a stronger electromagnetic attraction felt by the electrons and the radius shrink. That means overall, atomic radius increases, going this way on the periodic table. Ionic radius is a little different. Electrons repel each other, so adding an electron makes an atom bigger. Taking one away makes it smaller. Ions with the same electron configuration will have their radius decrease as the atomic number increases. Please subscribe to my YouTube channel. 2. Let's look at ionization energy. This is the energy required to remove an electron from the atom. It will always be an electron in the outermost shell. The electromagnetic force that attracts the electron to the protons drops off very quickly with distance. So the far away an electron is from the nucleus, the far away the electron is from the nucleus, the easier it is to pull it away. This means the ionization energy trend is precisely the opposite of the atomic radius. For instance, a very large atom with only one valence electron will be easy to ionize because the electron is so far away from the nucleus, and atoms like to have their outermost shell completely filled. Losing the electron means this shell is gone and the one below is completely filled. So elements in group 1 we easily lose one electron. Looking at the opposite corner, with helium, there is only one shell, so the electrons are very close to the nucleus, and the shell is filled, so it is very stable. For this reason, it requires much more energy to ionize helium. So the ionization energy increases going this way on the periodic table. Elements can have successful ionization energy for removing more than one electron. A second ionization energy will always be greater than the first and continue to increase from there. Since the more electrons you remove, the lesser stable the atom becomes, and elements will have a huge jump in ionization energy after you take the last one in a shell. Then you jump to the noble gas electron configuration from the previous shell, which is filled. So it really won't want to give up any more electrons. There are just a couple exceptions to the ionization energy trend, but we can rationalize them. Look, for example, at the second roll from helium to neon. The ionization energy should increase each time we add a proton to the nucleus, and the radius contracts a little. But something like oxygen, which dips downwards from nitrogen, ionization energy does so because of orbital symmetry. Here is nitrogen orbital diagram. As well as oxygen, notice that nitrogen's 2p orbitals are precisely half-filled. This gives nitrogen a special stability, just like elements that have a full outermost shell. If nitrogen loses an electron, it loses that special stability. But if oxygen loses an electron, it will gain the special stability. That's why oxygen ionization energy is a little bit lower than nitrogen. Even though oxygen has one additional proton, all diversion from the ionization energy string can be explained by discrepancies in orbital symmetry, like this one. 3. Next, electron affinity. This is exactly the opposite of ionization energy. Since ionization energy is how much energy you need to remove an electron, and electron affinity tells us how much an atom wants to gain an electron, disregarding the noble gases as their shell is filled. Electron affinity increases this way. Fluorine has the highest electron affinity because if it gains one electron, it will have a full shell or a noble gas electron configuration. Looking at the opposite corner, their electrons. These elements don't want to gain electrons. They could rather lose them. Expansions to this string happen for exactly the same reason as the expansions to the ionization energy. 4. Lastly, electron negativity. This is the ability of an atom to hold electron tightly. It will increase this way because a smaller atom, like fluorine, with more protons for its energy level or a higher effective nuclear charge, will hold electrons best. Again, we will disregard the noble gases for this strength. Electron negativity will be important where we learn about chemical bonding. Thanks for watching, guys. Subscribe to my YouTube channel so at any time I post a new tutorial, YouTube will notify you. And also feel free to message me at bigbesengombo@gmail.com. Facebook, Finda Besengombo. TikTok, Finda Blessing Besengombo. Instagram, Blessing Finda Besengombo. Feel free to message me at any time. And you can also leave a comment. Thank you.